Hey everyone, welcome back to ThinkTech. So today's podcast is about microservice versus monolithic architecture. So in today's software development world, one of the most important decisions that you can take is choosing the right architecture for your application. Microservice architecture and monolithic architecture are two of the most popular architectural styles that developers choose from, especially from the last few years. In today's podcast, we'll explore the key differences between these two architectures, the benefits and drawbacks of each approach, and the scenarios where one architecture may be a better choice over the other. By the end of this podcast, you will have a better understanding of the factors to consider when choosing between microservices and monolithic architecture for your application. So let's get started. So let's start with the very basics. What is a microservice architecture? Microservice architecture is a software design pattern that structures an application as a collection of loosely coupled, independently deployable services. So each service is responsible for a single business capability and communicates with other services using lightweight protocols such as HTTP or PubSub models like Kafka. One of the main benefits of microservice architecture compared to the traditional monolithic architecture is that it allows for better scalability and a lot more flexibility to developers. Each service can be scaled independently based on the demand for that service, and new services can be added or removed without affecting the rest of the application. Additionally, microservices architecture allows for more agile development as teams can work on different services concurrently as part of different scrums without worrying about code conflicts because each of their code will be deployed independently. This was something that was missing in monolithic architectures because in monolithic architectures, more often than not, you have a single code repository and then there are a lot of developers who are working on the same repository. So chances of code conflicts or introduction of unintentional bugs are a lot higher in monolithic architecture when compared to microservices architecture. So whenever we design an application using microservices architecture, there are some key principles that we should keep in mind, right? That makes the microservices architecture success. The first one is it should be a single responsibility service. Each service should only do one thing or serve one business capability and should not be coupled or bundled to perform multiple activities. Every service should be loosely coupled with the entire ecosystem, meaning that every service can be independently deployed and can be taken out in isolation without causing any problem to the rest of the system. So, and then finally, the deployment should be completely independent for the service. As we already discussed, that the service should be deployable independent of or without any impact to the other services. Sometimes what happens is that for monolithic architecture especially, if some team is trying to deploy a feature, then the entire application has to take a downtime and then only the deployment can go successfully. This is something that microservices avoids. It allows every team to deploy their own service separately without causing any troubles or any problems to the rest of the application. And as we said that each service should be responsible only for single capabilities. So that also means that it should not have any dependencies on other services, right? There should not be a dependency ladder or a dependency chain that slowly builds. This is one of the most important principle that we have to keep in mind because microservices, once you get a taste of this architecture, everyone starts using it and it goes out of hand, right? Very soon you will have more than 100 services running to maybe for a single business unit or a single organization. And if these things are not adhered to from the start, then it becomes very problematic to re-architect or refactor the code later. So these are some things that have to be kept in mind from the very start, that these principles should be very strictly adhered to. Now, even if we do that, there are several challenges that organizations or teams face when they adopt microservice architecture. The foremost is the increased complexity in deployment. So let's think about it. So if, for example, if we have one code repository where there is the entire code for the entire application, deployment of that repository is very easy, right? Because you just have to deploy that one repository and your code for the entire or the entire product will get deployed at once. But for microservices, it's a little different. You may have to interact with other services, and if those other services are not available or have not been deployed, then your service will get impacted, right? Then you will have to have some sort of a failure handling to ensure that unavailability of an external service does not cause any unintended consequences in your service, right? So this becomes a very common norm, and many a times you spend a lot of time coding for failure scenarios or for external failures in your microservices, which is something that is not a very productive thing to do, right? Because all these services, if it's an external service, then it makes sense. But when all these services are running inside the same infrastructure, are being controlled by the same product, same team, then half of the time if you're spending on failure handling of the other service, then it's not a good use of time, in my opinion. And the second most important challenge that we face is communication between services. So now what we have done is we have broken a monolithic architecture into multiple services. In monolithic architecture, any interaction between two parts of the code is maximum a function call or maybe a memory read write via some shared variables or some cache. But now what has happened is these services have been completely separated, and more often than not, they will be deployed on different infrastructure or different nodes belonging to the same cluster or same infrastructure. So now any communication, any sharing of state between these two services has to happen either via data storage where you store the state and the other service reads that state, or has to happen via a network call, right? Both of them are prohibitively expensive as compared to a memory read and write. So this again is something that very quickly becomes the main challenge for teams who are adopting microservice architecture, that their communication latencies become so high that they are not able to sustain or they are not able to scale any more than they sort of would have imagined when they were moving to microservice architecture. So as we also discussed, right, that one of the main benefit of microservice architecture is scalability, but you cannot scale beyond a certain limit because these penalties of network communication coordination becomes so and so expensive that you cannot tolerate that while also maintaining the serviceability of your application or user experience of your application. So there is a practical limit to how much you can scale. And that is why microservice architecture might not be a good fit for everyone or every application that wants to build a low latency or a highly scalable application. Also, if you want to adopt microservice architecture, you may need to invest a lot in new infrastructure and tooling to support these microservices. And this can be very significant. Very recently, Amazon Prime Video's blog post came out where they mentioned that they have moved back from microservice architecture to monolithic architecture, which has brought down their infrastructure cost by about 90%. So that much, or to that extent, you might have to spend on new infrastructure and tooling to support microservices. So until and unless there is a very strong use case that you should use microservice architecture, in my opinion, applications should avoid using microservice architecture until and unless they have a very, very strong use case. And now coming over to the data part. So another challenge that you face towards data is that once you move to microservice architecture, it is more difficult to maintain consistency and coherence across the entire application. This is something that is not inherent to microservice architecture. I would say this is something that is inherent to your distributed computing paradigm. So this is not that we'll discuss a lot in detail. This comes as part and parcel of using distributed systems, because as soon as you move a process from one node to multiple nodes, you will face consistency and coherence challenges. So now these were the challenges that we discussed. Now let us talk about some of the best practices that one should keep in mind for designing microservices. Right? So you should always make use of API gateways and service registries. These help you in scenarios where something goes wrong. You have a well-defined protocol of how the service should react and how the service if the service is registered back or is needs to be rediscovered, you then also have a set protocol how a service can be rediscovered via service registries, right? So this is something that we should use. API gateways provide a single point of entry also for external clients. So that is also one good thing, that there is just single point of entry for clients to access the application. And as I said, service registries along with discovery, they also help for communication. So it standardizes communication between different services. Another very important point is that do not create your microservices as stateful, right? Because they should always be stateless. One advantage of having stateless applications or stateless services is that they can be easily scaled. But the second more important benefit of designing stateless applications is that if a particular service crashes, or if one of the pod which is running that service crashes, you do not have or do not suffer any loss of data, right? So that is very important. Your services can be replaced in and out without any problem, right? So one of the biggest example I'll say in the tech industry that have successfully demonstrated the use of microservice architecture is Netflix. They have been the leader in using microservice architecture, and they have contributed a lot back to it. They have been using streaming platforms, and according to me, I think is one of the few companies who have been able to truly unleash the power of streaming platforms by building such a world-class product. And they were a monolithic application to start with. So it's not that they started with a microservice architecture. So they have also been to the migration journey. And I think that is what that has helped them design their microservice architecture in a much better way, because they already know what they want to get as an end result, right? They cannot be anything less than what they're getting already as a monolithic architecture, right? The performance cannot be less than that. The scalability cannot be less than that. So they already have a benchmark in mind, which I think is a good approach, because a lot of software advocates will also say, developer advocates will also say, a lot of authors also say in their talks that companies should build a monolithic application. They should not start with a microservice architecture. Once you have a monolithic application up and running, and once you start to feel the limitations that it has, such that you are not able to expand your product any further, it has reached to that point, then only you start deciding how you want to make a switch to microservice architecture. And because fundamentally you don't have to write a lot of code to migrate from monolithic to microservice architecture, you just have to sort of segregate or bundle your code separately. So it's not that it's a very difficult thing to do, but the intent or the expectations should be very clear of what you want to achieve once you move to microservice architecture. The next phase or the next emerging trend of microservice architecture is the serverless computing. We already have a podcast on serverless computing where we have discussed about serverless computing in a lot of detail. Serverless computing actually just allows developers to write and deploy code without worrying about infrastructure. So that is the biggest benefit that we get. And this is on top of containers. Containers also have been very popular lately, such as Docker, which allows you to package and deploy services in a very consistent and portable way without any platform dependency, right? So these are the things that have been, or I'll say that these things made microservice architecture so much, easy to use or easy to implement, that a lot of companies have the ability to move to this architecture. If these frameworks such as AWS Lambda or Docker would not have been there, then I think it would have been significantly difficult to break out from monolithic architectures and move to microservice architectures. So they have been a lot of help in designing applications better. Now, a lot of times people think of this as a debate between monolithic architecture versus microservice architecture. But what we need to understand is that it's not microservice versus monolithic, it is monolithic and microservice, right? You have these two different approaches, right? These are two different design patterns. We never say that there should be just one design pattern. We have design patterns. The use of design patterns is to help you identify where your use case fits and then help you guide how you should navigate through that use case, right? That is the only purpose of a pattern. So monolithic microservices are both two different software design patterns that are used for building applications, and both of them are equally good. At least in my opinion, I think both of them are equally good. There is no one better or worse. In monolithic architecture, the entire application is just built as a single self-contained unit. This means that all of the application's functionality is contained within a single code base. Now, it has tight dependencies with different modules or components, but that always is not a negative thing to have. And monolithic duplication is usually deployed as a single unit with all of its components running on the same server or set of servers. So I think all of these points today are looked as a negative or a shortcoming in monolithic architecture, but I don't think these are shortcomings. These are just the properties of this pattern. And for very long period, and even still today, a lot of applications have been using this architecture and have been running very successful products. So it's not that a monolithic is a thing of past or microservice is a improvement on monolithic. These are just two patterns that will coexist for a long time. So as we already discussed, so this was monolithic architecture, and then in microservice, if you just compare it with monolithic, it is a design pattern where your application is broken down into smaller independent services, and they communicate via lightweight protocols or pub/sub queues, right? A lot of times we see that communication between services are enabled via Kafka. So that is a very famous model that has been used by a lot of organizations. So use of Kafka to allow asynchronous communication between services has been very popular. And when you need synchronous communications, then obviously HTTP and your REST APIs are the most popular choice. So there are I'll say there are several benefits of using microservice architecture over monolithic architecture. One of the main advantage that we discussed as well was its ability for flexibility and scalability. Each service can be scaled based on demand, and you can improve performance and reduce infrastructure cost. But on the other hand, you will have to invest. So in monolithic applications, what happens is that once you have an infrastructure, if you want to scale, more often than not, the only option that you have is vertical scalability, right? You improve the performance or the specifications of the nodes on which your code is running, rather than running your code on more and more nodes, right? That is the general principle of vertical scalability. So in that sense, if you move to a microservice based architecture, you will reduce infrastructure cost, but you will have additional cost that will get added for maintaining and monitoring these services. So as I quoted the Amazon Prime Video example, so they basically were following the same principle of microservice architecture. They had a lot of step-in functions and AWS Lambda functions, and the article basically said that the billing per unit of execution of those functions became so prohibitive that they could not scale beyond a certain limit, right? So the very reason why they wanted to go to microservices or serverless basically was to scale, and it became so complex, so entangled with everything that they were not able to scale, if I remember correctly, beyond 5% of their total load, right? Or the expected load. So that is a big problem, and that is something that you will get very anxious about, because once you're stuck in microservices and then you're not able to scale, so you basically lose the entire purpose of making that shift, right? So that is very problematic, and that is why I say that you should evaluate it very carefully from the very start, whether you want to move to that architecture or not. And that is basically about infrastructure cost. And additionally, although microservices, one thing that I like about microservices is that it allows greater agility in development. So that can be a real pain, because if there are 100 developers who are working on single code repositories, then it becomes very, very painful to coordinate between all those developers, because they will most likely be working across different time zones, different working hours and all those things. And it becomes very difficult to coordinate and work on features together such that your entire application is running successfully and is not broken. However, we have seen a lot of massive open source projects who have been very successful and which do not have 100 but thousands of developers sometimes working on them. So again, that is not a debate which is better, which is worse. It's basically that both of these things have worked, right? And we have successful examples of both of them. So it depends on actually the use case of the application completely, of how, or the organization, of how they want to steer in their future. So basically, in summary, I'll say that monolithic and microservice architectures are both valid approaches for building applications. While we get more flexibility, agility, scalability in microservice architecture, monolithic architecture allows you simplicity, ease of creating applications, ease of deployment, as well as, in some cases, lower running cost and high performance. So you should be aware of these challenges involved and very carefully plan your architecture, so that once you make a shift, then you are not found, or do not found any unknowns, or you do not stuck with any of the things that you might have missed while designing them. So that is very important, because once you make a shift, then for at least a certain period of time you have to make it work. And if you get stuck, or if you're not able to perform better, then the purpose of that shift is lost, and it's not a good thing for a product to progress, right? So that is why it is very important to carefully plan, and as well as test your microservice architecture before you implement it, right? Because planning is one thing, but until unless you get on the ground and do some coding, or write some code, you won't be able to know what exactly is happening. So you should be spending time in creating POCs, creating, or trying out different communication channels for async communication, for synchronization communications. Try out what failure options you have, how strong is your infrastructure, how easy is it to scale in your infrastructure. So all those things, once you get on the ground, you get to know. So doing a lot of POCs before making the actual move is also very important. I think so that was it. I think this is a good point to conclude our discussion about microservices and monolithic architecture. We discussed basically the benefits and we discussed the definitions of both these architectures. We discussed the benefits of both these architectures. We also discussed the drawbacks that each of these architectures have, and then ultimately we basically concluded that there is not a debate between or it's not a monolithic versus microservice. It's basically monolithic and microservice, and both of these architectures will coexist for a very long time. Thank you so much for listening to this podcast. Please do not forget to follow this podcast, and be sure to listen to all our future podcasts as well. Thank you.